Okay, so this video is going to be focusing on one of my favorite topics in math, and it is on trigonometry. So, what is trigonometry? Trigonometry is the study of triangle measurement. I have to squeeze it in over here. The study of triangle measurement. So, each acute angle of a right triangle has the following trigonometric ratios, and these are very important, so make sure you get them down. And we're actually using this triangle over here that goes with these problems over here. So if we're talking about sine is the ratio of the leg opposite the angle to the hypotenuse. So what's sine of A over here? That would be written as A over C. So now look at this triangle over here. Since we're talking about the sine of A, notice the uppercase A and the uppercase A right there, we're talking about its opposite side. So that would be the lowercase a. So that's why I put the lowercase a over here. And then C is always the hypotenuse, so I'll just put C for hypotenuse. Same thing on the next one. So that's where I got my letters from. So let me erase this right here. So now if we're talking about sine of B, so that would be angle B right here, its opposite side would be the lowercase b. So then for sine of B, I would write that as B over C. Because remember, the hypotenuse is always C. And also, when it talks about ratio, that means fraction. So yes, if you see ratio, you want to put a fraction. So, moving on to the next topic, which is cosine. Cosine is the ratio of the leg adjacent to the angle to the hypotenuse. Adjacent means it's next to. So if we're talking about the cosine of A, so angle A, we want the one adjacent. So in this case, it's actually the lowercase b, since that is what's next to it. Because remember, C is hypotenuse. So for cosine of A, we would put B over C. So now, if we're talking about cosine of B, so angle B right here, the one next to it would be the lowercase a. So we would put cosine B is equal to A over C. Right, next one. Lastly, we have tangent. So for tangent, that is the ratio of the leg opposite the angle to the leg adjacent to the angle. So what does that mean? Essentially, it's going to be the two legs over each other. So for tangent of A, so we're starting with angle A, it would be the ratio of the leg opposite, so lowercase a, and then the angle to the leg adjacent. So then it would be A, then B. So tangent A is A over B. So now for tangent of B, we're starting with angle B. And once again, you start with the opposite side. So it would be lowercase b, then side A. So in this case, tangent B would be B over A. And now, here's a little hint to help you remember all that. So, we have a little catchphrase in math called so, ka, toa. It's supposed to be an A. So, and this is what SOHCAHTOA means. So sine is equal to the opposite over the hypotenuse, opposite over hypotenuse. Let me make that a little neater for you guys. HP over the hypotenuse. And then cosine is adjacent over hypotenuse. tangent is opposite over adjacent. So that's where SOHCAHTOA comes from. SOH, sine, opposite, hypotenuse. CA, so CAH, cosine, adjacent, hypotenuse. And then TOA, TOA, tangent, opposite, adjacent. So that's where all of that comes from. So now let's look at numbers 2 and 3. We want to list all of the trig ratios as a fraction in their simplest forms. So, first off, I need to know what my missing side is going to be, and you use that with Pythagorean theorem. So remember Pythagorean theorem, a squared plus b squared equals c squared. A and b are the legs, c is the hypotenuse. So with number 2, they gave us the 2 legs. We need to find our hypotenuse. So we're going to have 9 squared plus 12 squared equals, and then I'm just going to call it x. So put a little x right there. And solve. So when you square 9 and 12 and then add them together, it would actually be 81 plus 144. It's like squared. That's going to end up being 225. And then lastly, you do the square root on both sides, and your missing side is going to be equal to 15. So I'm actually going to erase this little x right here and put 15. Alright. Gosh dang it, I'm sorry. There we go. So now let's put all of our trig ratios. So the sine of W. So we're looking at this angle right here, angle W. Once again, you want to start with opposite over hypotenuse. So its opposite side is 12, and we know the hypotenuse is 15. So for sine W, we're going to put 12 over 15. And 3 goes into both of those, so that's actually going to simplify down to 4 over 5. Now for the cosine of W, we're still on W, that would be the adjacent over the hypotenuse. So that one is going to be 9 over 15. 3 goes into both of those yet again, and that's actually going to simplify down to 3 over 5. And now we have the tangent. Tangent, remember, is opposite over adjacent. So with W, the opposite is 12, and the adjacent is 9. So we're going to have 12 over 9. And 3 goes into both of those numbers yet again. So then this is going to simplify down to 4 over 5. Alright, so moving on. Now we need to find the sine of x. So now we're going to look at, let me actually do that in a different color. We're looking at angle x right now. So once again, sine, opposite over hypotenuse. So its opposite is going to be 9, and the hypotenuse is 15. So you'll get 9 over 15. And then that can be simplified down to 3 over 5. Now we're going to do the cosine of x, still looking at angle x. Cosine is adjacent over hypotenuse, so it would be 12 over 15. And then that simplifies down to 4 over 5. And lastly, we have the tangent of x. So opposite over adjacent. So 9 over 12. So 9 over 12. And then that will simplify to 3 over 4. And that's number 2. So now look at number 3. So once again, we're missing this side right here. But in this case, it's actually one of my legs because they gave us the hypotenuse and one of the legs. So go ahead and plug it in with 16 squared plus, once again, I'm going to call it x, plus x squared equals 34 squared. So when you get everything multiplied out and subtracted, you're going to end up getting x squared equals 900. Once again, do the square root, and that leg is going to be equal to 30. So I'm going to go ahead and erase the x and put 30. So now we're going to find the sine of angle L. Remember, sine opposite over hypotenuse. So in this case, it would be 30 over 34. So 30 over 34. And that is going to simplify down to 15 over 17, since 2 goes into both of those. Now we're going to look at the cosine of L. Cosine is adjacent over hypotenuse. So the adjacent would be 16. Hypotenuse is 34. So we're going to have 16 over 34. And then that is going to become 8 over 17. Once again, dividing by 2. Tangent of L would be opposite over adjacent. So we're going to get 30 over 16. Once again, opposite over adjacent. And 30 over 16 you divide by 2, and you would get 15 over 8. So now we're done with angle L, and now we're going to move on to angle M right here. So the sine of M opposite over hypotenuse, it would be 16 over 34. So 16 over 34, and that is going to simplify down to 8 over 17. Now the cosine of M, adjacent over hypotenuse, so the one next to it, so 30 over 34. 30, okay, let's try again. 30 over 34. And then that will become 15 over 17. And then tangent is opposite over adjacent. So that would be 16 over 30. So 16 over 30. And that will be 8 over 15. Let me go ahead and circle all these answers. And there you have it. That is trig ratios.